All right, so I'm building a new maglev, one that'll work with these two very large, I think they're 3.5 inch by half inch neodymium magnets. And I had to build a new housing for them, and I printed an extra safety strip to go around the outside. And then so these guys, this is where the ring magnet, the smaller ring magnet, is going to sit. And inside there, up against the back, I've got two pieces of glass. And in between the glass is sandwiched some plastic. And behind that is some foam. This stuff. It's actually, I didn't realize it, it's miniature bubble wrap. If you squeeze it, it snaps. Anyway, this will be the new stand for it. I'm working on the other half right here. Let that dry for a minute. And I put my old roller bearings to good use. I used them for a stand so that I could use longer bolts when connecting this guy to there. But the carbon fiber rod is about the same length as the other one, as that guy there. So once I get it more together, I'm actually kind of, I'm not being as careful as I was when I built this guy. I was much more particular on how I built it. This one's kind of down and dirty really quick. But anyway, once I get it finished, I'll show you guys what it looks like. So I also did something a little bit different with this one. I made these spacers to go between the end magnet and the ball bearing that goes up against the glass, because by itself, without the spacer, the magnet is too far in, or it may not be. The whole purpose of the spacer is I can adjust it to different, I can take it out. I printed out different size spacers. I just realized that this is going to be tricky getting this guy in there. Oh no, it's not too bad. But yeah, there's glass back there, as I showed you in the other one. And it's two pieces of glass. So let me get this puppy together. I think that one screw is strong enough. I mounted 4 bolts for this guy here for the end, but for the adjustment, I think 4 will be good. But now that I think about it, it's going to be difficult changing spacers out if I crazy glue this into the end here. Gonna have to think about that. I might not crazy glue. What I might do is put a dab of hot glue on there and just push it in there, and the hot glue will keep it from moving around, but it will be a lot easier to take out. So let me get this puppy together and see how it works. So in running a test, I tried it with the spacer, which brought the magnet out level with the ring magnet, and that gave it what I would consider a pushing force. So it was pushing it. I can't let go of this. It was pushing it in the direction of the other one. But without it, it captures it really nice, as you can see here. So I think I'm going to try it without. Yeah, this might even be better. All right, so I got it in there, and it was fairly easy, but I don't think it's as good as the pushing force. I mean, there's play there, but I have this weird You hear that? This weird clunking. And I don't know what that's from. I don't know what's causing that. Now, I don't have the brass rod in here yet. Oh, wait a minute. I think I know what it is. All right, I think it's off angle, because if you can see here, oh, it's pushing too hard on it. That's what it is. And I don't have them glued in. So that rocking is not the magnet rocking, it's the... All right, let me refigure this out. Because it works great, but I think I'm going to put a littler spacer in there and glue them in. All right. So I had to print out 2 more of these guys, and I made them a little bit deeper for the ball bearing. And I made the stem a little bit longer because the last one just broke. And I'm printing out 2 more of these spacers, but at half the thickness. This is 4 millimeters. I'm going to make them 2 millimeters because I want that pushing force, not the pulling force. The pushing force seems to work better, I think. I don't know why. I think it just does. So those 2 spacers are on the printer now. I also cut the brass rod and put it in there. And I think I've got to square this end off better too. I think that was one of the reasons why it was making that weird wobble sound. But let me go check the printer and make sure everything's cool. Also, in just checking the balance of this guy, I think there's going to be a difference because I have 2 magnets in there instead of 4 or 6 like I have in this guy. I've got 6 in this guy here. And that seems to help it to balance a little bit better. Yeah, 1, 2. Yeah, I've got 6 in this guy. And so he seems to balance a little bit better than this one here. And I'm not sure why that is. They're spaced perfectly. I mean, I did it using the machine. You know, I didn't eyeball it. The 2 end caps, or the 2 safety bands, are exactly the same. But yeah, so we'll have to see once I get it together. Let me go check that printer. All right, so it's all set. I should have made the spacers a little bit smaller. I don't know why I made them so wide. Kind of dumb. But I'm going to let the glue dry a little bit. I decided to go ahead and crazy glue it anyway. No big deal. If it doesn't work, I can just yank it out. But the back here is south. Oops, that's south. And that's south. And the front is north. And that's how it works. All south ends facing out, all north ends facing in, or vice versa. It doesn't matter as long as the like poles are all facing in the same direction. At least that's how I've seen most of the maglevs work. You could probably do it any old way as long as you get the magnet suspended. And again, this is a much smaller space I'm working with. And instead of that little piece of sheet metal I'm going up against glass. So this ball bearing against glass should offer really nice frictionless contact, where the contact point is just going to be right, where's my pointer? Is going to be right there. just right at that little tip there. All right, let me pause the video. I don't think I'm going to put a magnet on the outside here. I don't think it's needed from the little test I did. Maybe I'll do it anyway. And the magnets are so strong, I don't even have to glue it. They just stay there. So if I don't need it, I can always just pull it off. All right, let me get it set up. There it is. Nice and smooth. Yeah, see, the pushing is better. And you can see what I mean by off balance, which is really weird. You think it would be like this, but it's not. There's a heavy end on there. I'm not really sure, but it's quiet. And the one, hold on a second. Sorry about the camera angle. The one screw seems to work fine. And I don't really need the magnets on the end, just for show. All right, let me get a circuit under there and get it going. Holy shit, that thing is flying. Let me turn it down to just 12, 12 volts. That thing is flying, and it is humming perfectly. When it first started, I had to kind of hold this because it was, but once it got going, and then it made like a creaking sound, so I'm kind of staying out of the way. But holy shit, that thing is flying. I got to do a speed test on it. Let me pause this. So I just realized what the vibration was. It was the coil bouncing around, not this guy. So I need to fasten that coil down. And I used to have a device or a thing that I printed, a plug that sits in the middle of this coil and screws down to the base. Let me see if I can find it. So I'm waiting for my hot glue gun to heat up. I'm going to just hot glue it down. But that's what the vibration was when it was making those weird noises. And man, you got to love these JL94 circuits. Now, this is one of the ones that doesn't have the extra port for output voltage or output power. I need to, but I was thinking about that, and I think all I have to do, is jump off of where the neon bulb is. And so if I had a load on it, the neon bulb wouldn't light up. If I didn't, the neon bulb would, because right now the bulb is lighting up. And obviously I have this bifilar coil jumped so that it acts as one giant coil. But yeah, I think I'm going to do that. I think I'm going to just jump off of that and see what kind of voltage, or I can just take a reading off of it. In fact, let me try that. Wow, the hot glue gun. But I also have some JL94 circuit ones that do have the extra port. So let me just see if that's what he did, if he just jumped it. Yeah, so the only thing that's different is
Are you busy?
Hold on a second. Sorry, that was my son wanting some information so he can get something from his PlayStation. Anyway, I was looking at this guy, and there is an extra component. He's got a diode in here, and it looks like the diode So there's the in. This is the out. So the diode is hooked to one end. And none of it is hooked to the neon bulb. See, the neon bulb comes over here, and then over here, and then to the capacitor. But I could follow this and then just make the rest of these the same as this one here. Anyway, let me get this puppy mounted down and get a tack on this and see what kind of speed we're talking about. What's really interested, when I was putting this on, I thought I'd have to take it out because I wouldn't have any back pressure to manipulate this, but this thing is so tight in here because this ring magnet is very small. Anyway, let me get the hot glue gun. I don't know how much we got of that last one. Hopefully I recorded everything. I recorded taking a measurement off the neon bulb at 11 volts. We're running this puppy at 12.3 volts at 0.10 amps. It's making a lot of noise, but that's because of the stand I have it on, or the stand that I built for it. I got to put some rubber feet on there. Anyway, it's flying at about 4,000 RPMs. Freaking sweet. Let's see what I can do with it. Now that I think of it, I shouldn't have put these feet on here at all. I should have just let it lay nice and flat like the other one over there. I don't know if you guys can see it. The freaking mess. I got to clean up this shop. Most of that's my wife's junk. Anyway, yeah, so I think it's making a lot of vibration noise because of a couple of things. One, I only have one bolt on this here, but I don't think that's really doing a lot of it. I think it's mostly play in between here and the base bottom, but it runs really smooth. Really smooth. Let me hook up a Bedini circuit to it and see what happens. All right, here's the Bedini circuit, and I have the load over there. Some blue LEDs. I don't know if you can see them, but they're lit. I had to turn this down to 8 volts because it was just way too fast. And yeah, all that noise you hear is the vibration from the components, not from the rotor itself. It's a shame too. I should have taken more care to build a stabler system. But that's 8 volts. And then if I turn that off, oh, the neon bulbs, oh, they won't go on for 8 volts. So let me turn it up. That's 11.7. I'm going to back up because that thing's got me nervous. Yeah, see, if I hold this, there it goes. And if I turn that off, I'm going to turn it off. That puppy is flying. Yeah, it's got to be from the way I built the housing itself. And this thing is off balance a little bit. I mean, it looks like it's spinning fine, but it's definitely off balance. If I go like that, you look at. See? So I have to figure out why that is off balance like that. My other 3D printed rotors they don't have that issue. It may be because it just has the two bearings. I mean the two magnets. But it works freaking great. So I think I'm going to try to put the same setup with the bigger one. But it works good with the Bedini circuit. That was the whole point of this. Let me turn it down to like 6 volts. So that's 5 volts. And I'm still getting light from the LEDs. 5 volts. Five volts. And it's still working. I wonder how low I can go. There's 4.3, and I'm still getting output from the load. There's 3.8. It's still going. Yeah, that's definitely off balance. But I'm still going at 3.9 volts. Let me turn it up just a little bit. That's 8 volts. Still getting output. Cool, man. Turn it off. Stop it. So that's the Bedini circuit. Not as powerful as the JL94 circuit. This puppy causes it to freaking spin like crazy. I mean, the output is really... But I got to see if I can somehow modify these, which I'm sure I could if I just looked at it closely. Looked at the other one that he has, that he built, that actually has the output. I'll have to add a diode, a directional diode, and see. Anyway, I wanted to try to make a maglev with these smaller ring magnets, and it worked. And I'm using the glass. You can hear the bearing chewing on the glass. And the type of glass I'm using, I don't think is very good for this. It's this stuff here. I'm not sure this is really good glass. So G-Law gave me a good idea. He said, get the end of like a champagne bottle or a wine bottle because they're concaved or curved. And that would be perfect for something like this because it would trap the ball bearing. Anyway, wanted to see if I can do it. I did it. Let's move on to something new. Really quick, just what I thought. I don't know if you can see it. See that little black mark on the glass there? That was this ball bearing chewing it up. It's still flat, but you can feel a little bit of roughness on there. Not much. So that glass is definitely not good for this. So I'll have to, thank God I didn't glue these things. I just screwed them. So I can easily take that apart and change that out for either a stronger piece of glass or something else. Anyway, ciao. So the next test is to see if I can get this one to make this one run, to get this to run off of the excess power that this guy creates, not from the magnetic coupling as you see here. What's really cool is to get it to going in the opposite direction and get it coupled. That's really cool. See, normally that should be going this way, but I can keep it going like that. I've done that experiment before with other, but if we go like this, it'll go anyway. Yeah, some excess power off of this big guy or vice versa, something like that. Anyway, ciao.